Okay, so in this lecture we will find the coordinates of incenter, right? Let us say I am given a triangle with coordinates of the vertices and I need to find the coordinates of the incenter. So let us derive a method to find the coordinates. Let us draw a bigger triangle. And I am going to use basically two things while proving this, while finding the coordinates of the incenter. Number one, the internal angle bisector theorem. Internal angle bisector theorem, which says, let us say if this is triangle ABC, okay, if I draw the internal angular bisector of angle A and let it meet the opposite side BC, let us say in point D. So the ratio, this point D will divide this line segment BC in the ratio of these two sides AB and AC, which means that BD is to DC, BD is to DC is equal to AB is to AC, right? So if I write these in this the length terms, for example, this length is C, small c, this is small b, then I can say that BD is to DC is C is to B, right? This is internal angular bisector theorem. I hope everybody is comfortable with this theorem. Another thing that I'm going to use here is section formula. Then I will easily find the coordinates of the incenter of this triangle. Okay, so let us try and do that. Let me draw another triangle. I am drawing a big triangle so that I can easily visualize things, and it is always recommended in case of geometry that you draw the figures of big sizes. This will not let the board become messy, right? So I have given these vertices A, B and C and the coordinates x1, y1, x2, y2 and x3, y3, right? I know that the incenter lies on the angular bisector, so let me draw the angular bisector passing through this vertex A. So this angle is equal to this angle. Okay, let us say this meets the opposite side BC at D. Okay, so if I ask you what will be the ratio of BD is to DC, if this is small c, this length is small b and this length is small a, right? This is how we'll write the lengths. So what will be the ratio BD is to DC? We know that this will be in the ratio C is to B. Why? Because of the property, because of the theorem, internal angular bisector theorem. So this is C is to B. Now using section formula, can you find the coordinates of point D? Yes, it will be equal to Cx3 plus Bx2. So coordinates of this point D will be, coordinates of D will be Cx3 plus Bx2 divided by C plus B, comma Cy3 plus By2 divided by C plus B. So I've got the coordinates of this point D. But can you find the absolute length BD? What will be a length BD? So I've divided A in C is to B, right? So what will be the lengths of those segments? Obviously the lengths of those segments will be C divided by C plus B into A and C divided by B divided by C plus B into A. So the length of this segment here will be C divided by C plus B into A, and this segment here will be of the length B divided by C plus B into A. So if I give you 100 rupees and I ask you to divide it into the ratio, let us say 2:3. So what will be the values? 2 will correspond to 40 rupees and 3 will correspond to 60 rupees. If I give you 100 rupees and ask you to divide in ratio 2:3, so what will be the portions? It will be 2 by 2 plus 3 into 100 and 3 by 2 plus 3 into 100. Now this will give me 5 20 into 2 40, so 40 rupees, and this will give me 20 into 3 60 rupees, right? This is how I have written this length here. Okay, now if I draw the angular bisector of this angle here, angle B, and let it meet here, so what will be this point? This point will obviously be the incenter where this angular bisector and this angular bisector is meeting. Okay, so I'm interested in finding the coordinates of incenter. Let me change the color so that it doesn't become more messy. Now I know this length here, I know the length of this side here, and I know that this is the angular bisector. So this point I divides this line AD in ratio. I am again using the internal angular bisector theorem. So what will be this ratio here? It will be in the ratio of these sides, this side and this side. So this will be C is to this, CA by C plus B. Okay, now I have got the coordinates of this point A, coordinates of this point D, and the ratio in which this I divides this line AD. C is to CA by C plus B. Again, you can further simplify it because C is to CA by C plus B can be written as C is to CA by C plus B can obviously be written as, you can cancel these C's, right? Because we are talking about ratios, and you can bring it here. So you can write it as C plus B is to A, right? So which portion will be C plus B, which was previously C? So you can write this portion as C plus B and this portion as A in terms of ratios. These are not absolute values. So point I divides this line segment AD in the ratio C plus B is to A, right? Now it is very easy to find the coordinates of this point I. How? By just applying section formula. So if you apply section formula here to find coordinates of I, it will be equal to C plus B into the x coordinate of this point D, which is this. So C plus B will get cancelled. Okay, let me write it clearly. Let me make some more space here. Give me a moment. So what are the coordinates of this point? These are Cx3 plus Bx2 divided by C plus B, Cy3 plus By2 divided by C plus B. Okay, now let me erase this also. Okay, so now I've got the coordinates of these 2 points A and D, and I've got the ratio in which I divides AD, right? So I know that AI is to ID is equal to C plus B is to A. So to find the coordinates of I, let me apply the section formula. So the coordinates of I will be equal to C plus B into the x coordinate of D, that is Cx3 plus Bx2 divided by C plus B. So this C plus B will get cancelled, plus A into x coordinate of this point A, that is Ax1, divided by this plus this, that is A plus B plus C. So if we just focus on the x coordinate, you see this is Ax1 plus Bx2 plus Cx3, Ax1 plus Bx2 plus Cx3, divided by a plus b plus c, right? Similarly, I can find the y coordinate also, which will be is just symmetrical to this. That is, the y coordinate will be ay1 plus by2 plus cy3 divided by a plus b plus c. I hope you have got the idea how to find the coordinates of incenter when the coordinates of the vertices of the triangle are given. Okay, this is pretty simple. This involves only two things. One, the internal angular bisector theorem. The second, section formula, right? So this was very good application of section formula also.